All right, so here we go with the key from 4.4, 4.5, the second part. So we'll go ahead and get started with this. First things first, right? We always want to take what we got up here, are given. So we have two givens. It is segment BC is congruent to segment DC, and AC is congruent to EC. And of course, I'm not done there. I need to go over and draw them on the diagram here. So we're marking BC is congruent to DC, and AC is congruent to EC. Okay. And then we end up, right, this is also VAT. Vertical angles theorem says, right, two vertical angles are congruent, which our vertical angles are going to be here and here. So in other words, that would be angle. And so I just have to say what angle that is. So that's going to be angle BCA is congruent to angle DCE. And then finally, if we look at the diagram, we hopefully see that we have two sides and they include an angle, right? If I'm sort of sketching out one triangle here, we have side, angle, side, right? Two sides and the angle between them. So that is going to be side, angle, side congruence. All right. All right, next one here. It says that JK, we have some givens here. We have JK, right, is congruent. Oops, cool. Hopefully that's still recording. Is congruent to LK. And also JM, again, because they have the same reason, which is given in this case, we can keep them in the same step. So yes, we do know that is given, but again, just writing it down is not good enough. We need to put it on the diagram. So we have JK is congruent to LK, and JM is congruent to LM. Okay, and then we see reflexive property, and that would be, of course, of congruence. We would make sure we have that down. And we say, oh, that's got to be here. So reflexive property of congruence, so that is going to be KM. Segment KM is going to be congruent to segment KM as well. And again, we look on the diagram, we see we have side, side, side. We have all three sides. So we know it's going to be side, side, side congruence. And again, the proof, well, the whole point is that we are trying to get to prove these triangles congruent. That's the whole goal. So triangle KJM is congruent to triangle KLM. That's what I was trying to do, and I did it. All right. All right. In this case, we have angle G is congruent to angle I. That's already marked there. It's already in the statement, so that's why I put it. We also know that this segment FH, the segment is bisecting an angle. Okay? If it's bisecting an angle, it's splitting the angle into two congruent angles, which is what the next step says. Right? So after I write the given here, I'm looking at the next step, which says GFH is congruent, and I'll put 2 there, to IFH, which would be down here. And that makes sense, right? Because the whole fact is FH is bisecting this big angle, GFI. So this whole angle, GFI, is being cut in half. That's what bisected means. And so we have two congruent halves here, which means that this has to be the definition of angle bisector. That's what an angle bisector does. It cuts an angle into two congruent angles. So because this, in step 1, we have that it bisects, FH is bisecting angle GFI. So it's bisecting an angle. So it's splitting that angle into two congruent angles, which are GFH and IFH. Okay. Then finally, we have reflexive property here. So we know, and that's again of congruence, what we'd say. And again, we know that that's going to be FH in this case. It's going to be a reflexive side. You can have reflexive angles. Of course, this case, it isn't one. So, So we know it is a reflexive side there going on. And if I just look, I have this angle, I've got this angle, and I've got this side. So that's going to be two angles, right? Two angles. And then the side that I know is not between, it's not included between the two angles, so it's not between them, sort of here, it's outside of them. So we know it's going to be angle, angle, side congruence. And again, I'll just write in what we're trying to prove, and that the two triangles are congruent, because that's the whole point. It's right that we know it's one of the 4 reasons to pick from are going to be right. Basically, again, we could go back up, but essentially the reasons we had to choose from, we know we're going to be angle, side, angle, side, 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 and angle, angle, side, and then of course we have HL, but only for right triangles. So those are the 5 reasons we had to pick from. If we know the triangles are congruent, those are the reasons why we are proving triangles congruent. Those theorems. Okay, we're looking here. We have angle N and angle Q are right angles, so that is given. So we'll go ahead and mark that congruent right there. It says that triangle ONP, which is this ONP, this top triangle, and PQR, the bottom triangle, are what kind of triangles? Well, we look and it says definition of right triangles. Oh, so what it's saying is that because these are right angles, then these triangles that those right angles are in have to be right triangles. That's the definition of a right triangle, is that it has a right angle, and we know that those are right angles because that's given. All right, and it says reflexive property. Well, again, we're looking at a reflexive side here. I'll mark it with 2 this time, just for fun. So we know that's going to be OP is going to be congruent to OP or PO. Either way is fine. They're the same segment, so it's all good there. Again, I'll check enough congruence on there just because we're cool like that. And O is congruent to PQ. And in this case, we look back up. That's actually the second given that we're bringing on down. And now we do have enough. So if I sort of take a look at just one of these triangles here and say, okay, we have a side, we have another side, but the angle that we have, right? So if I have a side and another side, but the angle I have isn't here, right, in between them, it's not included between them, which would be the sort of this angle right there. It's on the outside, so it would be side-side angle. So this doesn't prove triangles congruent. But wait, right? There's another one. These are right triangles. If they're right triangles, HL is a possibility, and it actually ends up being hypotenuse leg or HL in this case, because what we have is that there's still three things we need. Right? It needs the right triangles. Check. We did that. They're right triangles. It says so in step 2. So again, we sort of deal with, they're right triangles. That's one thing we need. We need the hypotenuse, which in this case is a reflexive hypotenuse, which we have right there. And we need one of the legs, pair of legs being congruent to each other. And they are. So in other words, we know it's going to be HL in this case. Again, not all right triangles can be proven congruent using HL, but if you use HL, it has to be right triangles. I'll just fill in what we need, which is triangle ONP is congruent to triangle PQO. Okay, looking here, it says that ST is parallel to RU. So parallel, I'm going to go ahead and mark. Again, not congruent, parallel. So that is given. And then from the fact that they're given, right, we see, okay, well, these are parallel. We know that this is a transversal, and really the only angles that based on these parallel lines, that would be sort of part of these triangles would be this angle here and this angle here. And the reason why I'm looking at those alternate interior angles, because the reason says if the lines are parallel, then alternate interior angles are congruent. And so I look at the alternate interior angles that would be congruent, and that would be sort of this angle up here and this angle here. So those are the ones that would be congruent because of alternate interior angles. So I would just mark those angles. So the top angle there is angle STR, and that's going to be congruent to angle TRU. So TRU, bam, there it is. Okay. So now it says that these other lines, SR is parallel to TU, parallel, not congruent. So again, we have another set of sort of parallel lines that are sort of more vertical. We still have a transversal going like that, but these are the parallel lines in this case. And in this case, the only angles they give us the angles are congruent, right? Because this is given. They're parallel because it's given. Forgot to mark that. I forgot to write that, but I did mark it. Then it's telling me 2 angles are congruent, and the 2 angles they tell me are congruent are this angle here and this angle here, which again, if I was sort of looking here, it's like, well, how are those angles related? Oh, they're also alternate interior angles. So in other words, if the lines are parallel, then alternate interior angles are congruent. Okay. Come on, there you go. Okay, then we have a couple blank steps. Well, I'm looking at this triangle, right? And again, I'm sort of seeing that this triangle kind of, what we have so far is we have this angle up here. We have this angle right here. So we need something. If we get to the third angle, that doesn't help us because that's angle, angle, angle. So we need a side. And what side do we know? Oh, look, it's a reflexive side. So if I mark that side reflexive, in other words, so that side is RT. So I would actually say, well, RT is going to be congruent to itself. It's part of both triangles, that segment RT. So that is going to be reflexive property of congruence. And now we hopefully see that we have 2 angles, right? 2 angles. And where is the side? Oh, the side is included between the 2 angles. So we know it's going to be angle, side, angle congruence here. And then that's because the reason why these triangles are congruent is going to be angle, side, angle, right? So the triangles are congruent, which I'm writing right now. Triangle SRT and triangle UTR are congruent because of angle, side, angle. All right, finally, this one's very similar to 4. It says that the angle W and angle Y are right angles. W and Y are right angles, and then that is given. So, I mark them because they are right angles. Mark them, and they're given. And in this case, we're saying, oh, well, because those are right angles, we can say that these are right triangles. Now, really want to keep in mind that right angles can be used as congruent angles for side angle side, for angle angle side. They can be used as congruent angles. But they also, so there's 2 directions we can go with these right angles. One, we can say that they're congruent to each other because of right angle congruence theorem, or all right angles are congruent. Or we can say that, oh, these are right angles, therefore these are right triangles. So if we use the fact that they're right triangles, that pretty much means we're going to be looking for HL, right? Because HL requires 3 things, and one of which is that it's a right triangle. But if we use it for any of the others, right, any of the other side, angle, or angle, angle, side, if we use it as one of those congruent angles, we would need to state that the right angles are congruent to each other, and that was just because of right angle congruence theorem. In this case, though, we are looking for HL, and again, if you sort of glance ahead, you see that this is the midpoint, and we know these, so we actually are having HL. So if you kind of know where you're going with this, then you'll sort of know what you have to prove. So in this case, we're like, okay, well, with these 2 right angles are there, therefore we could say, triangle VWX and triangle ZYX are right triangles. Okay, so if they're right triangles, and that's the definition of a right triangle, right? A triangle is a right triangle when it has a right angle. So it says, hey, look, in step 1, they're right angles, therefore those are right triangles. Okay, then we bring back the sort of, or actually we're bringing down the givens here. So Vx is congruent to Zx, so Vx is congruent to Zx. And again, that's just marked, and that's just given in the diagram. In fact, both of these are. And the second part here is that x is the midpoint of Wy. So x is the middle of Wy. So what I would do is say, oh, because x is the midpoint, I could say that this segment and this segment are congruent. So I would not only mark it in the diagram, but I would write it. I'd say Wx has to be congruent to xy. And the reason why they have to be congruent is because that's the definition of midpoint. The definition of midpoint is saying, hey, if something is a midpoint, it's splitting a segment into 2 congruent segments. So I said, oh, it's the midpoint. Bam, we have 2 congruent segments. And so finally, we can prove that triangle VWX is congruent to triangle ZYX. And we look at the diagram and we think, okay, well, again, we have a side, but it's a right triangle. So if we have, this normally would be SSA, except it's a right triangle. So because it's a right triangle, we know that HL is on the table, and that's what this is. Because, hey, it's a right triangle, check. It has congruent hypotenuses, check, and it has congruent a pair of congruent legs, check. So we're looking, bam, we got HL congruence there. All right, see you on the next one.